Welcome to MrCScience.com's video on changes in matter. We're going to talk about how matter is changed through chemistry. Talk about a few different ways. The first way we're going to talk about is scientists like to categorize things. So they categorize changes in matter in two separate ways. Whoops, that didn't work. Okay, physical and chemical. So physical changes in matter are changes in matter that occur where the atoms or molecules are not changed. Say you have a sheet of paper, you rip it up into tiny little pieces. It is still paper chemically, so the atoms and molecules within that paper have not changed at all in their organization or their bonds. Chemical changes, though, are a little bit different. If you take that same sheet of paper and you light it on fire, now the energy is going to allow the cellulose in that paper to interact with oxygen and produce carbon, carbon dioxide, and water vapor. That is no longer cellulose. Those atoms have been rearranged, changed, so that they no longer can go back to the way they were, but they are no longer cellulose. Now they are something new. So that is a chemical change in matter. So physical change in matter, the atoms and molecules stay in their same condition. They don't rearrange. Chemical change in matter, now we rearrange those atoms. So first thing we're going to really talk about is physical changes in matter. A major physical change in matter, especially in chemistry, is phase change. Phase change comes in, for us, one of three types: solid, liquid, or gas. Any of those three. So you should be relatively familiar with what solid and liquid and gases are, but let's talk a little bit more about what occurs when that happens. So let's give ourselves a little room here. Okay, so let's take a solid. Solids generally are atoms, can be molecules as well, but they are all very close to each other, often with some kind of cohesion or bonding between them that keeps them together. Solid atoms are next to each other. They still move. As you add heat to a substance, it moves, but solid matter is kind of bonded to each other, so that movement is in the form of vibrations. So those atoms will vibrate in place. The hotter you get, the more vibration you get. So until you get enough energy that those atoms or molecules can start moving amongst each other. So now you can get some movement. They've broken those bonds or whatever cohesion was holding them together, and they can move and slide through each other. Now there may still be some cohesion going here, so they may still be holding on to each other a little bit, often called surface tension or cohesion. Also, a liquid is still very much acted upon by gravity. So gravity will still keep the liquid from wandering across the room, so floating up in the air. So that's going on. So if we got a relatively low temp, now low, it's a relative term, but if we go to a medium temp, higher than we were before, we can change that solid into a liquid. If we continue to add heat to it, eventually we can get it enough heat that those molecules or atoms will gain enough energy that they will start moving away from each other. They'll have complete motion. There will be no bonding or cohesion between them, and they will be still interacted upon by gravity, but gravity will have much less of an influence on them, so they can wander. If gravity went away entirely, our gases would just diffuse off into space, and we would have no atmosphere, and we would be dead. So that would be no fun. So as we add heat, so this is high heat, again, relative to high heat. So low, medium, and high, you can only go so low. You can go to what's called absolute zero. I can't spell. That's where all this atomic motion stops. There's no longer any motion of the atoms. So you can only go so low, but you can go as high as you want You can go infinitely high. You can continue to add heat and energy to it, and they will continually get hotter and hotter. But you'll have these places of state change, though, freeze thaw, and condensation and evaporation, or boiling. So phase change. So these are our phases and our phase change. Now these phase changes bring us into another concept in chemistry called density. You've probably run across this. I can't spell. Density. Run across this concept in other science classes, but density is basically the amount of stuff in a given volume. So it's the mass divided by the volume. And in general, solids are higher densities, gases are lower densities, liquids are in between. So generally, a solid is more dense than a liquid, which is more dense than a gas, and vice versa. So generally, solids will sink in liquids, and gases will bubble up through liquids, so that the density stays the same. So we got our solids on the bottom, our liquids in the middle, our gases in the air. Now this is true for almost all substances, but there is an exception. Water. Water is a little bit different. Water, the gas is still the least dense. Water vapors. The gases wander around. Here's our little waters. And they're still free of most of gravity's pull, things like that. They can still escape. But where the change comes is in liquids and solids. Now, remember our waters are H2O, and it forms a bent molecule. And also, oxygen is much more electronegative than hydrogen. In fact, everything's more electronegative than hydrogen. It's generally the poor stepchild in the family. Everyone takes everything from it. So oxygen will hold on to those electrons much more tightly than hydrogen. So those protons on the hydrogen will be partially exposed sometimes. So water, as we said, is a polar covalent molecule. It's got negative and positive charges. Because of that, it attracts to itself. The negative hydrogens or negative oxygens attract to the positive hydrogens. Positive hydrogens attract to the negative oxygens. And because of that, its liquid form is much more tightly held together than its solid form, at least its early solid form. It'll cause a cohesion, which causes our surface tension on our water. So you probably remember that's caused by what they call hydrogen bonding, those hydrogens and oxygens bonding together here. But so liquid water is actually more dense than solid, with the exception of ice can become more dense as you cool it down. It gets colder and colder, you're getting very extreme temperatures, but you can drop ice to a point where the solid is more dense than the liquid. But generally, liquid and solid ice interact with each other around 0 degrees Celsius, and at those temperatures, or around the temperatures, the solid is less dense than the liquid. So the solid ice will float on top of the liquid water. This is an interesting design because it allows us to have life in our northern climes here. Like we're in Minnesota, it's turning into winter quickly here, so the lakes are freezing. Now, if solid ice was more dense than liquid ice, they would freeze on the top, it would sink to the bottom, and the lake would freeze from the bottom up and kill all life in it. But because that solid ice can float, it freezes on top, which kind of creates a thermal barrier and makes it harder to freeze the stuff that's underneath. It's got to cool the ice and work its way down, so life can survive in the lakes under the ice and be ready for the next year. So that's kind of a talk on chemical and physical change and density. If you have any questions, contact me at Mr. C at mrcscience.com. Thank you.